Hey calculus folks, I'm going to do a quick rundown of the notes that we looked at today in case you need to go back and listen again. So we were finding limits algebraically. That means we're not looking at the graph, we're not looking at the table, okay? All I'm doing is giving you a function and I want you to find the limit of it. All right, so there are three techniques that we need to use when finding limits algebraically. All right, and the first one is the most important. All right, and that is you always start with direct substitution. Okay, always start with direct substitution. Okay, then if you get 0 over 0, all right, you try another technique. And you're only going to try one of the other techniques. You're not going to be able to do them all on the same problem. So try another technique. Now later we will talk about other options, like a number divided by 0. But right now we're going to stick to either direct substitution works or you get 0 over 0. So what are my other techniques? Okay, well, you could, if the problem allows you to, all right, if it's the right type of problem, you could factor and reduce, all right, and then you direct substitute. Okay, or if the problem doesn't lend itself to factoring, maybe you can rationalize. All right, and I'm going to say and reduce. I really mean rationalize and reduce, or, okay, so, or just simplify. So rationalize and simplify or just simplify. I kind of put them in the same category, and most people do. Then, of course, you go back to direct substitution. Then direct substitute. Okay? All right, so, again, when I say direct substitute, I mean that when you take the limit, you, I'll show you when we get to one. Okay, let's look at some examples. Okay, so for my examples, the directions will be to find the limit. Okay. And so for my first one, I have the limit as x approaches 7 of pi. Okay? Now when I say direct substitute, what I really mean is whatever x is approaching, you're going to direct substitute that into the function in place of x. Okay? The thing here is there is no x. So if I can't plug 7 in for anything, then the function is still pi. And so that's my answer. And there's actually a rule, all right, and you can make yourself a note. Anytime you take the limit of a constant, you get the constant. All right, so if we look at another example, what if I said the limit as x approaches 3 of 7? So 7 is my function. Well, I don't have an x. So I can't plug 3 in place of anything. So the answer is just 7 because the function is still 7. And if you think about that in terms of a graph, it's a horizontal line at 7. So if I take the limit, it doesn't matter what I'm approaching, what x value I'm approaching, I'm always on that horizontal line of 7. Okay? So again, that just had, like, make yourself a note, the limit of a constant is the constant. Okay, the answer is the same constant. All right, so let's get into ones that, at least one that you can actually direct substitute into. All right, so number 3. All right, we've got the limit as x approaches 3 of 4 minus x. Okay, and I want to know what that equals. So this time I'm going to direct substitute the 3 in place of x because there is an x, and 4 minus 3 is 1. Okay? And the direct substitution problems are that easy. All right, next. All right, what if I ask you for the limit as x approaches 1 of the rational function x squared minus 1 over x minus 1? Well, direct substitution, if I plug in 1, I get 0 over 0. Notice I'm not writing equals because you're not allowed to equal 0 over 0. That's called indeterminate. Or some people say it's in indeterminate form. Well, that's because in the form that it's in, you cannot determine the limit. All right, so then we have to move on to our other techniques, and because we have a polynomial on top, that happens to be the difference of squares, the technique that we should try is we should try to factor. All right, so I am going to factor the numerator and reduce. All right, and then that leaves me to take the limit as x approaches 1 of just x plus 1. All right, and now I can direct substitute, and 1 plus 1 is 2. Okay, so that's how the factoring one works. All right, let's look at another technique. Oh, got a little sloppy there. Limit as x approaches 0. We've got the square root minus 1. Okay, so here we go. All right, well, again, you still start with direct substitution, but that would give me the square root of 1 minus 1 on top and 0 on the bottom. So that's indeterminate, so we have to try something else. Well, because we're dealing with square roots, it's not something we can factor. It's not something we can just simplify what's already there. And so that's where the rationalize technique comes in. Rationalize is just a fancy term that means get rid of the square root, okay? Get rid of the square root. And the only way to do that when you have a square root plus or minus something else is to multiply by its conjugate. So the stuff under the square root doesn't change, but conjugate means it's a binomial with an opposite operation in the middle. So it's the same binomial, the square root and then the 1, but then one's a minus and one's a plus. And you have to keep things balanced. So anything you multiply on top, you multiply on the bottom. All right, and then just make sure that you don't lose your limit along the way. Now, we need to simplify all of that before we can do anything else. All right, and so that does require me to technically FOIL. All right, so first outer, inner, last. But I will tell you, conjugates, we use them for a reason. Conjugates will always cancel the 2 middle terms, so I really only need to worry about what first times first gives me and last times last gives me. All right, and then on the bottom, because they are not conjugates of each other, I am not going to take the time to distribute. And there's a reason for that. Okay? All right, so if I direct substituted now, I would still get 0 over 0. So I need to keep simplifying. Well, you have to make sure you do it in the right order. Okay? So the 1's cancel. All right, so mathematically the 1's cancel, they disappear completely. And then the x's reduce, but there's still a 1 on top. Okay, so kind of running out of room. All right, so I still have to take the limit as x approaches 0, but now my simplified function is 1 over all this stuff with the square root in it. And then I can finally go back to direct substitution, and when I plug in 0, I get the square root of 1 plus 1. So my final answer is 1/2. Okay? All right, that a couple more for us. Number 6. I'm just trying to give you different examples of when you would use the different techniques. All right, so this one we have a fraction within a fraction, but I still try direct substitution first. When I plug in 0 for x, I end up with 1 minus 1 over 0, which is in fact 0 over 0. That is not okay. All right, but it's not a polynomial. I can't factor anything. It doesn't have square roots, so I can't rationalize anything. But because we have fractions within fractions, we can actually simplify what's already there. Okay, so I'm going to take a second and I'm going to write down what's already there because I want to talk about how you would simplify. So what I mean is I want to figure out a way to get the two things on top, right? And I'm going to treat this one as a fraction. I'm going to figure out how to get those two fractions together. So I need a common denominator. So I'm going to multiply this one by the denominator that I want over itself, okay? And so then I technically get, and you have to be real careful here, because you have to distribute that negative with the 1. So we get 1 minus x minus 1. And then it has a common denominator, and then the whole thing is still over x. And I apologize for switching to red. Hopefully that doesn't bother you too much. Okay, I still have to take the limit of it, but it's not simplified yet. On top, these 1's cancel each other out. I'm going to go over here, sorry. And so then I have the limit as x approaches 0 of negative x over x plus 1, and then that whole thing is still divided by x. Well, how do you take a fraction and divide by something? Well, why don't we turn it into a fraction, and then how do you divide by a fraction? You multiply by the reciprocal instead. So I'm going to, instead of division, I'm going to multiply by the reciprocal. And then when I multiply those two fractions, I can reduce the x's. And now I can hopefully finally take the limit. We now have a negative 1 on top, x plus 1 on the bottom, and there is no other bottom. That's the whole thing. And direct substitution now gives me negative 1 over 1. Okay, so those are really, I mean, I pretty much gave you all the options for needing the other techniques. I just want to extend the whole idea of direct substitution just a little bit. So I have 2 more examples for us. All right, so if I ask you to take, let's say, the limit as x approaches pi over 2 of sine of 2x, okay? Well, I'm going to start with direct substitution. So 2 times x, well, that's going to be 2 times pi over 2. That's just pi, okay? And then sine of pi is a value on the unit circle that you are expected to know, and the answer is 0. All right, and then last but not least, I want to make sure you know how to do the reciprocal functions. All right, so let's say I ask you for the limit of pi over, as x approaches pi over 3 of cosecant of x. Okay, so direct substitution gives me cosecant of pi over 3. But I have to remember how to evaluate that without a calculator. And pi over 3 is on the unit circle. But cosecant is not on the unit circle. Cosecant is the reciprocal of sine. So if I can figure out what the sine of pi over 3 is, all right, then I can flip it over, and that's the answer to cosecant of pi over 3. So I do have to remember a little bit about the unit circle, and I will tell you that the sine value at pi over 3 is the square root of 3 over 2. So when I go to the cosecant, I just have to flip it over, and then I have to rationalize. And so my final answer to my original limit is 2 square root of 3 over 3.